Hello everyone, this is Dr. Song. Welcome to my YouTube video. So finally we are in week 3 of a quantitative research method course, and then we were talking about last session, the standard deviation. So in the descriptive statistics, this is the very important part we are now going through. So the second concept is about the variability, range, outliers, skewness, and kurtosis. So I will talk about this today. First, I want to show you what are sources of my course. These are three professors' name and then their quantitative research method course. They are the like references for my course. So if you remember last time we were talking about the standard deviation. So that means that is from the mean value. So we have the graph like this, yeah. So that is the distribution of the data, and the mean value is here. This is a mean, and then that is 25, and then you have the standard deviation is 5. So if you remember, we had the standard deviation 1, standard deviation 2, and then standard deviation 3. So that is the standard deviation 1 and then 2 and the 3 dimension. Standard deviation 1, that covers the about the 68% of the data, the distribution. And then the second standard deviation, that is include the 95% of the data. And then standard deviation 3, this one, that is about the 99% of your data is included. So here they say that it's a 95% means that standard deviation 2, that is the area. So that is you will do that standard deviation 1, you will add the 5, so it's a 30. Standard deviation 2 is a 35, so it will be the 35. And then in the left part, you will deduct the 5, so 20. Standard deviation 2 will be the 15. So this is the range of this level. That is also the 15, and this one is 35. So that is the question. So sum of squares, variance, and the standard deviation all represent the same thing. That is about how much the deviated from the mean. So that is we saw that last time, and you can see the last video. We obtain first the sum of squares, and then we divide by the n minus one, total number minus one, and then that is a variance, and then you do the square root. That is a standard deviation. So we and find what are the deviation amount. So what value is associated with the minus 2 standard deviation? Okay, so this is a SD2, but it's minus 2. So you should go to the left side. So the mean is 25. So it's a distribution here. That mean is a 25. And then standard deviation is a 5. Now you have to go to the left side because it's minus 2. So first, the 25 minus 5, that is SD1, that is a 20. Now SD2, that is a 15. So you have to say that that is a 15. And then what value is associated with the plus 3? So this is the standard deviation 3 from the mean. Okay, so this is a plus, so you have to go to the right side. So the mean is 25. This is a 25 here. And then the SD is 5. Now you go to the 3 times. So SD1 is a 30. SD2 is a 35. Yeah. And then SD3 will be the 40. Okay. So this is a 40. So I hope you understood how it works with the standard deviation. So now central tendency and then variability. So variability is about the maximum and the minimum value. So now you know the central tendency, that is about the average number in the interval ratio. However, when it's a nominal data, you cannot calculate with the like average number, because you cannot make average of the gender, like a man and a woman. You can find what is the most frequently appeared, but not with the average number. And then ordinal data, you can obtain the median and then also the mode. That is the most frequently appeared, and the median is the middle value. So this is possible because ordinal variable has low and high. So you can say that between low and high is a median. So you can obtain the median as a central tendency. And the interval ratio variable, they are numbers. So you can obtain the what is most frequently appeared, what is the in the middle value, and then what is the average value. So you can obtain the every three kinds of the central tendency. So be careful about this. When you see the nominal variable, you can obtain the central tendency with the mode. Okay, only mode. And then when you see the ordinal variable, you can obtain the central tendency with the mode and the median. And when you see the interval and the interval ratio variable, you can obtain the mode and the median and the mean. All three central tendency is possible. And also with the standard deviation. So about the variability, when we talk, standard deviation is only for the interval ratio variable. So when we talk about the other variables like nominal and the ordinal, how we can obtain the variation ratio, how much they are deviated from the mean, that is we used another formula. But first, let's see the range, the minimum and the maximum. Maximum minus the minimum and then plus one, that is the range. That is the value of the range. Now, variation ratio, let's see that. So when you see this formula, the variation ratio that is obtained by the 1 minus, and the n is the total number, and the f model means that is a frequency, so that is a central tendency of the mode. So central tendency of the mode, you say the f model. So how it works, let's see that. So you can see that here that is the nominal variable. Liberal Party, Conservative Party, NDP, etc. They are not possible to provide the average score because they are not the numbers. And in that case, how will you will know this data is a very much variation, like a variability is a big or small. Like they are very various distribution, or it's a very concentrated on the mean. So for that, yes, yeah, I wrote here. The one is means that is very diverse. So it's like when you see the data will be the very flat. So that is a very much diverse data. So you can obtain that one minus, and then what is the central tendency of the mode here? Is a liberal party is a 4,265. What is the total? Is a 12,733. So you will divide the frequency, the central tendency mode divided by the total number, and you will obtain then 0.665. So this is very close to the 1. So we can say that this data is quite variable. So you can obtain also percentage. It's a 66.5%. So they are very much variable. It's more than 50% because it's less than 50% means that it's less diverse. Okay, you can obtain like that. And then also we can use the variation ratio with the IQB. This is more complex. So I recommend you to use the more this variation ratio than with the IQV. But anyway, I can explain a bit. So this means that you can put it's like a theoretical equality. So they have the one, two, three, four, five parties, and then you distribute the same frequency, and then you have the percentage also, the valid percentage is the same. So this is really like a not real. It's like a theoretical concept. So you can just like a hypothetical concept. Yeah, so you can distribute the exactly same for the five groups. But in fact, the reality is this, is the left side. So in the left side, you can see that they have the frequency the 3, 3, 2, 1, 1. So this is not distributed equally like a right one. So this is a reality. Now you can how you can calculate that. So that is the observe the difference is first is the 3, yeah, and then it's a you can see that the other possibility is a 3, 5, 3, 2, and 5, 6, 7. So 3.7 you put that, and the second one conservative party is a 3, and now you have only 2, 1, 1. You have the 4 possibility of 4, and then 2 is only 2, etc. So you will make all these things, and then that becomes the 38. And then now you put a hypothetical idea situation. You put the when it's a 2, you have the 8 possibility remains. So you will multiply by 8. when it's a consecutive party, you have the sixth possibility, you put the six, etc. So this is a hypothetical situation. So that is 40. So 38 divided by 40 is 95%. So that means that it's a very much diverse. It's a variability is a big. So that is a IQV. Yeah, so you can see the here another example, but just I will go very briefly because I explained about how you can obtain that like a basic theory. So that you will use the same thing, observe the difference, and then this is the maximum hypothetical difference. So you will make that calculation, and then the observed difference is this, and then theoretical difference is this. And then that is divided is 0.937. So that means it's very close to the 1, and it's a very variable. And we cannot say that that is very concentrated in the central tendency. It's a very variable data. Now let's talk about the percentile rank. So quartile and the box plot, everything. So percentile and then percentile rank, that is about very simply, percentile is like you know that is 100% from the 1 and then 100%, and then you put the rank. So how you can calculate that? For instance, the 30th percentile, so that is the 30%. And then there is about the 90 cases. So you put the 0.3 and then 90 becomes 27. So 27's score, that is whatever the score, that is the 30% of that data. Okay, so you can find that. So let's see about uh, the next slide. But here also another way to obtain the about the percentile is that the divided by the so here if the given score is 21, and then how you know how much percent that signifies, and then you can say the counted cases are 40 or all of them, and then you will divide the 40 and by the 90, and then that is a 44.4%. So if a 21 score, that is about 40, and then you will say that that is in this data is about the 44.4%. So you can see here the in the this table cumulative varied percent. So when you see the percentile of 25%, when you see that is a 20, that is not yet 25%. So you have to go to the next line. So that is 5. Yeah. So that is 5. That is a like a 25% higher. And then 75 is the percentile you want to know. And then you go to the cumulative percent. 72 is not yet 75, so you have to go to the next. So it's a 9. 9 is the 75% of the that score, and then here is a 5 is a that 25% of the score. So the range is between the 25 and the 75%. That is 9 minus 5. Sorry, 9 minus 5. So the range is 4. So you will obtain like that way. And then quintile means that is each 20%. So 20% is here. So you will say that 4. And then the 9 that is like 80%. So here is 80%. So 9 minus 4 is a 5. So the range, quintile range will be the 5. And then decile range, that is about 10%. So that is a 10 minus 3, so it's a 10, and then that is a 3 is a 7. So 10 minus 3 is a 7. So that is about tenths. You will go to the tenths. So we use the more is about the percentile, the quartile. So it's a 25%, 50%, 75% like that. That is the most used. But this is the way how you can see the cumulative valid percent to find the 25% and the 75%. Okay, so today I have to finish here, but I will make another YouTube video to explain more about this descriptive statistic part. Thank you very much, and then see you next time.